All right. In the name of God, the compassionate, the merciful. This is the second session of our Idris part of the module. We are going to try, given that you guys are hardcore Haskellers, we're going to try to finish this chapter in one go. I usually don't do that. I usually give this in two sessions, but because I have seen you guys on, during the previous sessions, I think that you would manage. So I'm going to go fast. So right, this chapter has a lot to explain by taking this listing 2-1 here as the running example. A lot of it is explanation of the syntax. Now, how much of this is visible?
We can see it.
Yeah.
You can read it?
Yeah.
Yeah.
Okay, very good. Very good. Now, so given that you guys know the Haskell syntax, I know that you know what a let binding is. So I'm taking it that you understand this part of this the story. I mean, just try to put that out. So this is a let binding with an in statement, which is called a let expression. So you define you bind a couple of variables, and then you have an in at the end, which gives you the expression that you would like to return. Now, the definition of these, the binding of these variables requires a number of functions that are defined here in the word clause, which again is something you have seen in Haskell, right? Now, what is different in Idris is that at least for the top level functions, like the average function, the type declarations are compulsory, right? Now, some of the times there are ways that you can get away with defining functions without giving them strict types, and we are going to see some of those situations in this chapter. But so you see in the word clause also, even though we are not having a top level function, we provide the definition preceded by the type declaration, right? For example, this word count, please.
What's the difference between the typing on average and word count? See, on average, it looks like string has been defined, or str has been defined as string, but in word count, it still looks like it's from Haskell. It looks the same.
Right.
Is it just different ways of doing the same thing?
Thank you. That was actually a nice question. The thing is that so there is type deduction in Idris, and so in this case, because we are calling like this words thing on string, Haskell can deduce. Sorry, you meant to ask about. Let me.
Yeah, I was asking about like.
Are you asking about this part of it? I think I
it looks
initially.
like yeah, it looks like they're doing the same, but different ways.
Right. Yeah, I have to revert. So what I said about type deduction is not relevant here. I initially thought you were asking something else. Now,
Okay.
so the reason why this string thing is here is to demonstrate to you the possibility of this string variable contributing to the typing. So if it would have been that we needed this variable itself inside the typing of the next typing compartments, like for example in the return type, then we could have used this str variable itself in the typing of the things here, right? So we saw something of that nature in the last yeah. So you see, it's here in get string or int. We could have just said bool, and then x would have simply shown up down here, but because we wanted to utilize come on, because we wanted to utilize that x in here in the typing of the return type, then we explicitly named it within the type declaration, right? Now this is one of the many building blocks of having types as a first class citizen, right? Now this variable is not different. Oh, come on, what is this? This variable is not different from type variables. There is no distinction between them. Therefore, it can participate in the typing, right? Now, let's get back to chapter 2. Now, so what else? Right. Now, it's time for me to tell you what this piece of code wants to do. So this piece of code is a REPL experiment. It asks the user for a string, and then it returns the average length of the words in that string, right? Now, there are a number of building blocks that it's using. Some of the syntactic ones I told you about, but the idea is that you have a function that takes a string and returns a string, which is this function, and you pass that function to another function called REPL, which is a built-in of Idris, and you also pass it a prompt. So every time the prompt wants to every time the REPL is reloading, the prompt shows up, the function that you pass is called, and the return value of that function is displayed as soon as you pass it the value. Well, the user of the REPL passes the value that it is taking as the input. Now I take it that this function show average you can read, right?
Yeah.
Now there is something, and you can understand as Haskellers, right? Now there is something here which is different from Haskell. It's that string is a standalone type. It's not a list of characters, right? It's a standalone type. Now, what else? I think pretty much everything here you understand. And I take it that, like, as Haskellers, you know monads and all that. So you know the IO monad, and you can understand like this bit. Come on, don't do. Oh! Wrong shortcut keys. Oh. Oh, by the way, I last week I showed you my kind of cobbled up slides, which not the book. This is the book itself. I'm going through. Now my slides are, like I said, I usually deliver this chapter in two goes rather than just one. But I decided that this session I'm not going to show you my slides. And by the way, there are annotations on my slides, so which come from the previous time. I don't have the pure slides, so I'm being lazy as well. Let's see. Yeah. Okay. Now, so there are loads of things about the primitive types and the differences between integers and doubles and all that. One thing which you, I think, want to familiarize yourself with is that there is in Idris, in the built-in types, there is int, which is a fixed width signed integral type, but there is also integer, which is on bound, right? So you have and you can also have like arbitrary precision floating points, but we're not going to get into that for the moment. Now nat is just like integer, but it's unsigned, and double is also a standard floating point, which means that it's a fixed length, right? But there is also support for arbitrary precision floating point. And now I will skip through these because I'm sure you guys will be able to figure it out yourselves.
Sorry, can you quickly,
please, James?
Could you go back a page about? I was just reading something here, the subtraction with nats, because nats can only be subtracted from a larger nat. Is that type checked?
Yes. So
wow.
So like,
okay.
Yeah. Yeah.
That's all.
So okay. Right. Now, so you having spoken about type checking and all that, you can figure out pretty well why this doesn't work, because the typing don't match. But there is a reason why this is brought up. More than just typing, it's trying to show you the syntax that it used in the running example. So what this is showing is that, okay, double val has a type double, and integer val has a type of integer, and these two don't mix, right? But there is this utility function which comes in the prelude of Idris that takes a look at what type it requires, and it performs the casting to that required type for you without you needing to explicitly state the type. There is also support for when you as the programmer want to state the type to which you want to cast, and that function is called the, right? Right, which is this one. Right? Now, if I say the integer of this thing, then I get the integer back, right? If I say that I want the double of caster 4 plus 4, right? Now this expression itself is not of type is not of type integer. Sorry, it is. And then, but anyway, I want the double of it, so I get in return like 8.0, which is a double, right? Mikhail, are you good?
Yeah. We were just testing the subtracting a bigger nat or like
Uh-huh.
Yeah.
Right. Yeah. Okay. Great. Now, what else? There are special characters. This is a character. Sorry but you know, plethora of syntax. This is just the first you know, place where you get to see the syntax. This is a character, this is a string, they are different. The first one is a single quote, the second one is a double quote. There are special characters like these ones. And there are a number of you know, prelude string utility functions. So for example, you can get the length of a string, you can reverse it, you can perform substring extraction, you can what is it called? You can is that juxtaposition, right? So you can juxtapose like strings together. So hello
Concatenate?
Concatenate, yes, concatenate, right? So you can and this is just like Haskell. So you have these things all the time. Or you have them for breakfast, I don't know. Right. Now there are booleans. You know that I'm gonna just fly through them. Right, now function types, it's just like Haskell again. The only difference is that you need to also provide the type declaration. So if I want to have a function called double, which takes an integer, an int, and returns, oh, what is happening? No, it doesn't like me. I don't know why. If I want to have a function double that takes an int and returns an int, then I have to state that, and then only then I can provide the body of the function or the function definition. Now this is where the question of Mikhail is revisited, right? So you see that it's saying that we could have done this if we were about to use or utilize that value thing, just like we saw in the previous chapter, that there is that possibility, because X wants to participate in the typing of the function. Now, you guys know about partial application of functions. The syntax is the same as Haskell. And you know about genericity. So by the way, if I'm going at any point, if I'm going too fast, just stop me. Right? It's I just don't want to bore you up. That's the reason why I'm flying through them. And now, so you guys know about genericity. So if you want to have an identity function for integer, for ints, this is the way. And you want to do the same for strings. This is the boringly repeated pattern. And the same for booleans. You do this 2 or 3 times, you think, well, come on, I need to do something for all of them. And what is new is this part. Now, the identity function here has a type declaration which says, I take a type variable, which, by the way, we should grow the habit of calling them just variables, because we are in the world of Idris where there is no difference between type variables and ordinary variables, right? So it takes a variable, right, and it returns a variable, and that's a type. Now this being the typing of the function identity, Idris can at this point figure out that this is a type variable, right? Therefore, when you do this, it knows that there is genericity involved. This is a type parameterized function. right? That's what we call in better terminology, we call that an instance of genericity by type. We're going to see that in a few sessions. Now, now you guys have already seen the function that is called the, right? Now that the function takes a type variable and then takes a variable, or sorry, takes an input of that type and returns an output of that same type, right? Now, so the takes ty as the type and an x, and it returns an x, right? Now that's then therefore the reason why you get these partial applications of functions. You know, if you want to see the type of int, you're actually passing int for that type variable, right? And therefore you get to see the rest of the type declaration of the int to be int to int, right? The same with string, the same with bool. Is everything here understandable? Right.
Yeah.
Now, this is new. Now you see that in this instance we are stating that, well, ty is a type. Who can tell me why we needed to do so?
Because you're kind of dealing with sort of layering in a way, which is you need to know that it's an integer in that case so that you can make it the integer identity function.
Layering.
Yeah, as in it's sort of.
Are you speaking about currying?
No.
No.
Sort of because the question was, why do you need to name that type?
Yes.
And it's
no. Why can't I just do it the way with identity? So why do I need to say that ty is of type? Why can't I just say the is a function from ty to ty to ty? Ouch.
Because it isn't, because it's got to receive, you're receiving the type as a value, and then the other two arguments, the value is a member of that type.
That's
as opposed to, yeah, that's what I meant by layers.
Okay.
That's what I meant.
I see. Right. Yeah, that's true. So here it's just we are receiving a type, and then we are receiving instances of that type and returning instances of that type, right? Whereas here we're not receiving any types. We're just parameterizing the identity function according to a type variable that shows up twice in the type signature, because we're taking instances of that type variable that we implicitly that Idris deduces implicitly and returns. So identity returns well, possibly different instance of that type. And like James said, that's different from here, because here we're explicitly dealing with the type. We're taking it, is taking that type as a variable. Now, thank you, James. Right. Now, if you try to do double in the same way, you will fail, and you Haskellers know that, because you know this plus that you're using needs to be defined in a type class. Now in Idris, type classes are called interfaces. it's a matter of taste, you know. It's and there are very slight differences, but anyway, the idea is the same. So if you want to do a generic or type generic, I should call it genericity by type double, then you have to say that this type variable has to have certain properties. It has to be of a certain interface. And the way you say that is this. You say that provided that tie is numeric, then double takes instances of tie and returns instances of tie. So that's how we do that, which is pretty much the same with Haskell.
Can I ask a question?
By all means.
So the num type class in Haskell is really annoying because it's got loads of operators in it that you wouldn't define on many numbers. I wondered if that was the same in Idris, if it's gone down the Haskell type, or if it's just sensibly got like, because for example, say I'm modeling an age, for example, like age of a person. Does it ever really make sense to multiply ages together?
Right. Well,
so but you might want to do some adding, you know, for example, like, so I dividing them, who knows? So like, and sometimes your numbers that you're modeling are more like a semi field anyway.
Sure.
So I just wondered if Idris is sort of a bit more precise than the Haskell version.
Well, num is not your best friend for that, but there are more refined, or better to say, less involved numeric services that you can get, right?
Yeah.
Now, let's see. But in the next chapter, we'll get into doing some of the Idris commands, and you know, you get to ask the Idris command line about the documentation of different type classes, or as Idris calls them, interfaces. And so you can get to experiment with these things yourself. Okay, now do you get the noise that I'm getting? Like there is gardening happening?
No.
Okay, very good. Very good. Then that means that I can keep the window open. Right. Now, so if you take a look into the typing of you know, some of the familiar operators, then you can get to see that, for example, in this one there is a requirement on type to be numeric, and this one it is required to be equality, or as it's put in Idris, num and EQ, and this one needs to be ordinal or odd for the type to be applicable here. Now, one thing about the Idris syntax is that, as you can see, these guys they are within the pairs of these operators are within pairs of parentheses, and that's because the these are infix operators, and if you want to use them as ordinary functions, then you put them inside pairs of parentheses. By the way, I like around 15 years ago, I came to realize that the Americans call these round brackets, parentheses, they call them round brackets. Right. Now, you guys being Haskellers, you take higher order functions as breakfast. It's the sugar you pour in your tea or coffee. So you guys know that very well. You know, if you want to send functions as arguments to other functions. You can do that in Idris pretty much the same way you can do that in Haskell, and therefore you can do things like, for example, you can write a function called twice, which takes a function of this type, and then it takes an instance. It takes an instance. Oh, I'm not going to try it again. An instance of the type of the input of that function and return an instance of that same type. And so you see that f here has a, I said I'm not good at it. Anyway, f is a function, and x is a non-function variable, and they sit together nice and tightly, and there is no problem with that. And you can perform the familiar partial function application that we talked about. Essentially, you're performing eta reduction here. So like this quadruple thing, it says that this takes a variable of type A, which is a type variable here, and which is implicitly deduced by Idris, and it returns something of that type. But you see here no variable, which means that we have performed an eta reduction. You guys are familiar with that? Yeah. Okay.
Yeah.
Good. What else is around? Right. Now, I think I should. Right. You guys know about the anonymous functions. It's the same syntax in Haskell and in Idris. And you can pass these anonymous functions into right. One thing here. So if you take a look at the typing of, well, let me highlight this. So if you take a look at the typing of the anonymous function, you realize that it says that it's of type integer to integer. How does it know that? Niels?
Because we used multiplication, so it like infers.
Okay, very good. That's true. That's true. And the default, the default for multiplication is integers, but we can also change that default, like what we do here. Right. So anonymous functions can also take can state the type of their arguments, right? That's how we do that. What else? There is you guys know about let binding and all that. Yeah. Next, and this is usually a position, sorry, this is usually a place where I pause. So I'm gonna ask Mikhail to spare us his joke, please.
Okay. A second. Okay. The spread of a virus depends on two factors. Number one, how dense the population is. Number two, how dense the population should be.
Well, that was. I'm sure that was very nice, but I missed the very beginning, so I'm sorry I didn't laugh. I didn't mean to be rude. I just didn't hear you.
Number
I'm
one.
Sorry.
Don't stop now.
The spread of a virus depends on two factors. Number one, how dense the population is. Number two, how dense the population is.
Why don't I get it?
Dense also means stupid.
I didn't know.
If you say,
okay, right,
it's like saying
okay.
he's thick or he's dense.
Right, right. Oh, I see. Okay, good. Thank you. Right, that was a good one. Thank you. That was a linguistic one. Very good.
Yeah.
Yeah. Okay. Good one. Right. Thank you. Now, so yeah, let's get dense. This is pretty much dense. So let's see. Yeah, you have tuples in Idris, and that's you can also have an empty tuple, right? You are familiar with lists as the bread and butter of Haskell, so I'm sure you know what these guys are. And now, so here is a bit of a difference between Haskell and Idris. So in the type the constructors of the interface string are like this, whereas in Haskell, for the empty list you get the square brackets. Then there is, it's not that you can't use the square bracket, but it's that's a kind of shorthand. It's a syntactic sugar. And then there are the familiar syntactic sugars of Haskell that you are very familiar with. Yeah, you have a certain number of lists. There is a library that is in the prelude. I don't think it will really surprise you. Now there is a function called map in that library, which has this type declaration, and this is to tell you that there is yet another interface which is called fonter, and I know that you know that, so I'm not going to bother you. What else? Yeah, so we get back to the original running example of this chapter. What else? Now the new thing that is happening is that so it's trying to show you that you can package your material in Idris by giving your package a name, right? And then saying what things you want to export. So this is it, as you probably recall, the running example had two functions, and what it is saying here is that this is the only function that matters to the outside world. So the other one is a utility function for this. Yeah, that pretty much is it. Right, now you can perform nesting in the packages, as we're going to see. Right, I think the rest is easy. Yeah, so my slides helped me, would have helped me with the parts of the chapter that I would like to cover, but now that I'm going through the book, I'm afraid I have to scan through. My apologies for that. Now, getting back to the question that James asked about num, right? I said that there is the possibility of looking up the interfaces of interfaces. Sorry, the interfaces of interfaces, the documentation of interfaces. So you, in the same way that you use :doc for looking up the typing and the rest of the documentation of a function, you can use :doc to tell you about the documentation of interfaces. And in particular, you can replace this list thing here with num. Was it num? Did you ask about num, or was it nat? Right.
Num.
Yeah. Right. And you'll get to see the documentation, and you get to see how many functions it provides. Right. And the way you do that, so there are these Java doc or Scala doc, or as in C++ we call them the gen things. So you usually you put like // so triple slash. In Idris it's triple bar. So you get to see like triple bar just before you put that before the entity that you would like to include in the documentation, and by doing so, as is done here, then you get to tell Idris that if someone looks up the documentation of this function, then this is what you would return. So and that can be multiple lines. I'm not going to go through that. Yeah. Now I told you about REPL being a built-in in the prelude, but that too has documentation that you're welcome to look into. Okay, that's us. And you guys being so fast, we managed to finish this chapter not only in one go, but also 15 minutes earlier. So, do I have the pleasure of questions?
I have a question. I
Oh,
was
thank
trying
you.
the REPL, but I can't seem to find it on like using the doc REPL.
Right.
In Idris 2, you have to import something. It was in the docs for the changes.
Right, indeed. Thank you very much, James.
Yeah.
Yeah. So do you have the so I'm going to stop sharing. Do you have the link handy to the oh, Sunder didn't
I do
show
here.
up. Right. Oh, right, you do. Okay, I was
I'll
asking.
put it on.
Right. Yeah, that's great.
Hold on. There we go.
Yep.
Yeah.
So it's system.REPL.
Yeah.
You need to import all capitals for REPL.
Okay.